Welcome to this session, students. Myself, Anirban Sarkar, Assistant Professor, JIS College of Engineering, welcoming you to all of you to this session. So we are discussing today, our subject is energy conservation and management, and today we are going to be discuss module 3, which is about total energy concept, CHP cycles and their applications. Now, first of all, we have to understand what is the need of this CHP cycle, which is comes under the cogeneration process. Now we know that thermal power plants are the major source of generating electrical power in India. So as we have discussed, that is nearly 55 to 60% of energy coming from that is burning of coal. Now if we consider the electrical power generation, nearly 65 to 70% of electrical energy that is coming from the burning of thermal power plant mainly is coal. Now the conventional power generation and supply to the customer, it becomes wasteful in the sense, as we know, that only a fraction of energy can convert into the useful energy. Now we know that from the thermodynamics point of view and the limitations of the thermodynamic cycle, so if we put 100% input a fuel, merely 30 to 35% energy can be successfully converted into high grade energy, and remaining 65 to 70% energy is lost. The major source of loss in the conventional process is the heat rejected to the surroundings, water or air, due to inherent constraints of different thermodynamic cycle, as we know, during power generation. Also, it is found that around 10 to 15% losses are associated with transmission and distribution of electricity in the grid. So a major source of power, that is input power, is losses, and if certain percentage can be recovered, so which will be very much helpful to our society, because we know that fossil fuels are, firstly, it is depleting, as we know. So we need to be conserve the power that as much as possible. So we need to be think about that, or we need to be revised about our technology, so that the maximum possible efficiency we can get from the thermal power station or from the other sources. So mechanical efficiency or a device efficiency is very much important from this subject point of view. So the concept of cogeneration comes now, that is the principle of cogeneration, that is cogeneration or combined heat power cycle. This concept came, as we know that thermodynamically, if two cycles are connected in series, then their overall efficiency will be greater than any individual cycle efficiency. For example, thermodynamic point of view, suppose a conventional power plant can produce efficiently 40% of energy, and another plant suppose 30% of energy, So combinedly, if these two plants are combined in series and we are applying single fuel or single sources of fuel into the plant or into an plant 1, and the rejected heat from the plant 1 is again going to be utilized in the plant 2, thus the overall efficiency of the plant can be greater by any individual cycle. So suppose, for example, suppose 40% is the first cycle efficiency and 30% is the second cycle efficiency. So overall efficiency, as we can get, that is nearly 58%. That is a thermodynamic relations is there, that is eta overall is equal to eta 1 plus eta 2 minus eta 1 into eta 2 for simplified version. Now cogeneration or combined power cycle is defined as a sequential generation of two different form of useful energy from a single or primary energy sources, typically mechanical energy and thermal energy. Mechanical energy may be used either to drive an alternator for producing electricity or rotating equipment such as motor, compressor, pump or fan for delivering various services. Thermal energy also can be used either for direct process application or for indirect producing steam, hot water, hot air for dryer, chilled water for process cooling. Cogeneration provides a wide range of technology for application in various domains of economic activity. The overall efficiency of energy use for cogeneration can be achieved up to 85% in some cases. So from this way we can save the energy as well as we can conserve the energy for the future, and as well as we can utilize the input energy in better way. So typically, if we consider that is fuel is 100% is input is providing in a power station, so effectively suppose its efficiency is 40%, so wasting of power, that is 60%. And again, if these waste heat recovery systems are there, such as waste heat recovery boiler, etc., so it can, that among that 60% useful energy, that is waste energy from the first cycle, can be regained by this waste heat recovery boiler if it is 85% efficient. So that is, we can recover more than 34% of heat from the waste of first cycle. So now overall losses will be, that is only the 42%, and for an CHP plant, that is overall efficiency now is 85%, where electricity during the first cycle generation is 24%, and for other industrial processes heat utilized is 34%, and overall loss is, that is only 10%. This is the cogeneration advantages. So for example, that is given, and industry suppose requires 24 units of electrical energy and 34 units of heat through separate heating and power route. The primary energy input in power plant will be 60 units. If a separate boiler is used for steam generation, then the fuel input into the boiler will be 40 units If the plant has cogeneration, then the fuel input only 68 units to meet the both electrical and thermal requirement. It can be observed that the losses, which were 42 units in case of separate heat and power, has reduced to 10 units in cogeneration mode. Along with the saving the fossil fuel, cogeneration also allows to reduce the emission of greenhouse gases. So greenhouse gases, the effect of greenhouse gases, as we broadly discussed in earlier videos, so it has many harmful effects to the not only the making the greenhouse is making more and more gases, that's we are depleting ozone layer, etc., and also some harmful gases also is producing, so that in day to day human life are also getting affected during the various pollutant that is causes by during due to industrial and from our vehicles. So the production of electricity being on site, the burden of utility network is reached and transmission line losses eliminated. Now, so as we know, for the cogeneration, as we can see that less amount of carbon dioxide particularly and other harmful gases are emission, that is due to the cogeneration plant. So there is an overall reduction in the greenhouse gases, and there is an ultimately we are saving the fuel and the loss is minimum. Cogeneration makes sense both macro and micro perspective. At macro level, it allows a part of financial burden of the national power utility to be shared by a private sector. In addition, indigenous energy sources are conserved. At the micro level, the overall energy bill of the user can be reduced, particularly when there is a simultaneous need for both power and heat at the site, and a rational energy tariff is practiced in the country. So this is the principles of cogeneration by which we can save more and more energy, and the burden of customer at our end level, that is energy tariff, etc., that can be also minimized. Now, technological options for cogeneration. These cogeneration technologies have been widely commercialized, including extraction or back pressure turbine, gas turbine with heat recovery boiler, with or without bottoming steam turbine, and reciprocating engine with heat recovery boiler. The examples of these, that is steam turbine cogeneration system, gas turbine cogeneration system, and reciprocating engine cogeneration system. So one by one we will be discussed about this, that is the steam turbine cogeneration system first of all, then gas turbine cogeneration system, etc. So ultimately we understand that this we cannot ignore, or the device which have today's generation, that is all devices are generally run by the electrical power. So generation of electricity has become very important over the few decades, and due to the rising in consumption and growing environment awareness, new requirement we need to be met. The power supply has to be constantly adapted to the scoiotic requirement to the consumer for the consumer of electric energy, except that they can use this energy at all the time and it may quality desired. However, now we see that electrical power cannot be stored in appreciable amount, although we can absorb this one with our battery, etc., but that is also required huge amount of investment and huge amount of area also, and the efficiency is also, battery also need to be improved, and that is also, that is time consuming to grow that, to make that such arrangement. So as a whole, the bulk amount of energy, electrical energy, cannot be stored. The electricity is producing and need to be consumed very fast. So this means that it has to be produced at the time when it is needed. So difference between generation and consumption result in deviation from the adjust target value of the network frequency and power delivered to the customer. Now you see, we see that in some industrial processes like refineries, chemical plant, sugar industries, etc., they uses substantial amount of electrical energy. In addition to this, that heat energy, that is in terms of hot water or steam, is required for chemical reaction and for heating purposes, for drying purposes, etc. A further task to be accomplished is to generate the thermal energy at a certain steam pressure and or steam temperature, that is a certain steam quality. This makes building a local combined heat power station on site a sensible option. So the CHP power station can utilize steam turbine, gas turbine and internal combustion engine, or both steam turbine and gas turbine together to generate the electricity. So it is called, that is combinedly, when a gas turbine or steam turbine, or when the both are steam generation unit, when a gas turbine is co-generated with the steam turbine, when a gas turbine is co-generated with reciprocating engine such as IC engine or etc., that is called combined cycle power generation. This combined cycle or combined heat power plant offers the highest available energy in both commercial and industrial applications, where both power and thermal process demands are required. So a combined power cycle, how we defined a combined cycle? It is a power plant system in which two types of turbine, that is combined cycle, namely a gas turbine and a steam turbine, are used to generate electricity. Moreover, the turbine are to be combined in one cycle so that energy is transferred from one of the turbine types to another. The combined cycle can be used to produce only electricity or can be employed within the combined heat and power scheme to produce both electricity and steam. Combined heat and power plant, CHP plant, sometimes called cogeneration plant, produce electricity and heat as a whole. Heat is extracted as steam or hot water and exported from the system to the required place. Combined heat and power process can be applied with conventional steam processes without gas turbine, or it may include a gas turbine. Now the cogeneration or combined heat power generation can be defined as a sequential use of primary energy sources to produce two forms of energy, basically heat and power at the same time. A cogeneration system, that is consists of major component, that is a furnace converting chemical energy into heat energy, engine or turbine as a prime mover, generator which converts mechanical energy into electricity, heat exchangers, electrical switchboards and hydraulic interconnections. The fuel burned in the furnace is converted first of all into thermal energy and then into mechanical energy of steam. The fuel burned in the gas engine or gas turbine is converted into mechanical energy and thermal energy. The mechanical energy drives generator to produce electricity. Heat exchangers are installed to recover the wasted thermal energy contained in the exhaust gases of the gas turbine, of the internal combustion engine or the steam generator, in the bleed steam or exhaust steam of a steam turbine, in the cooling water of the internal combustion engine jackets, or it may be the lubricating oil and in the turbocharger. Up to 85% of thermal energy can be utilized in this way to generate steam or hot water, which is the subsidiary requirement of the various industrial and chemical or process purpose. Electrical equipment distributes the electricity. Pipeline transport of hot water or steam is sent whenever it is required. So this is the technicality behind the combined power generation or combined heat power generation. Now, what are the advantages we are getting? High electrical efficiency up to 40%, high total efficiency, that is overall plant efficiency, it may be up to 80 to 85 to 90%, and extremely low emissions due to the use of clean natural gas in combination with lean burning concept of catalyst. Lean burning concept. Modern lean burning engine systems stay clearly below legal emissions standard for thousands of operating hours without a catalyst to reduce NOx emissions. So in this way we can save the environment also, and the auxiliary equipment that is used for conventional power generation to reduce the emissions etc., that is also get reduces, as this combined power generation is extremely low emission due to clean natural gas in combustion and lean burning concept. Now, partial load efficiency and multi-module plant makes gas engine cogeneration the most flexible cogeneration system, as we want to discuss later. Clear? So, first of all, that is we want to discuss, that is steam turbine cogeneration system. So, in a steam turbine cogeneration system, as we can see, there are two types of steam turbines are most widely used, are the back pressure and the extraction. Back pressure turbine and the extraction. And another version of steam turbine, that is topping cycle cogeneration system, is the extraction back pressure turbine that can be employed whether the end user need thermal energy at two different temperature level. Now, in this steam turbine topping cycle cogeneration system that can be employed whether the end user need thermal energy at two different temperature level, the full condensing steam turbine are usually incorporated at sites where heat rejected from the process is used to generate power. So the specific advantages of using steam turbine is comparison with one prime movers is the option for using the wide variety of conventional as well as alternative fuel such as coal, natural gas, oil fuel and biomass can be used. The power generation efficiency of the demand of electricity is greater than 1 megawatt up to few hundred of megawatt. Due to this system inertia, their operation is not suitable for site with intermediate energy demand. So as we can see that steam turbine cogeneration system is not friendly for generating the electricity, bulk amount of generating the electricity. As we can see that this amount, this is a back pressure turbine. As we can see, this is called a back pressure turbine. A back pressure turbine, this turbine is called back pressure turbine. So whenever the turbine, that is it uses its primary needs is not to generate electricity and to produce the process heat. So it is practically using in industries, the sugar industries, chemical plant, etc., where primary electricity is coming from grid and the secondary option is to generate the process heat. So instead of a condenser, conventional condenser, here we have a process heater where the steam is coming from the turbine is utilized for the heating purposes, and such a process heater is very much useful in case of generation of heat. So it is mainly used in different industries. So in this system we cannot use bulk of energy electricity produced. Some small and medium industries where the ultimate need of the process heat, in that case the process heater along with this suitable turbine, that is called back pressure turbine, they can use. And considerably amount of fuel that is supplying, that is also adjusted in case of back pressure turbine. In another case, that is called extraction condensing type of turbine, where some amount of process heat is required and although the electricity is also required. So it is also utilized for an industrial cases where the main aim is to produce electricity as well as the process heat. So in this case, as we can see, during the expansion of the steam in the turbine, that is bleeded out and sended, a part of steam is sended in a process heater and remaining steam is expanded conventionally and a condenser is also there to produce the sufficient amount of electricity. So this type of steam generation is suitable for medium to big scale industry where their own electricity and the process heat they can adjust it with the what amount of steam bleeding will be there, etc. So as per requirement they can adjust it with this one, with this type of extraction condensing turbine. So they may utilize this type of system. So in this case also, that is, bulk amount of energy are not produced, which is commercially need to run the various industries, other industries where that heat is not primary needed. So this steam turbine cogeneration system that reduces the possibilities in the wide area, as we can see that it is limited to a few small medium scale of industry where the process heat is mainly requirement and electricity is secondary things. So with this, that is steam turbine cogeneration system, but it is advantageous as one industry cannot this cannot depend on the electricity board. So if they are in chemical industry or etc., there are lot of waste things are there, they can use as as a fuel to run the boiler, and they need the process heat also to supply for need for its various chemical processes. So these two are not useful for the bulk type of energy needed that conventionally a thermal power plant do, but it is very much helpful where the process heat is required. So this back pressure turbine and the extraction condensing turbine, these two turbines or these two steam generation systems are utilized in industries, chemical, paper mill industries, some sugarcane industries, rice industries. They may utilize, they can install this back pressure turbine or this extraction condensing type of turbine for their own industrial needs, and they can get the electricity to run their own equipment, and if the excess energy is there, with permission they can send to the grid also. So with this we are ending today's part, and next session we will discuss the gas cogeneration and the other systems of the CHP cycles. Thank you for joining this session. Thank you very much.